Hi, everyone. In 1999, as we were about to enter not only a new year, but also a new millennium, people were busily amusing themselves by compiling lists of the greatest minds of the millennium, that is, from the year 1000 to 1999. And at the top, or near the top, of just about everyone's list was Isaac Newton. So this week, we're going to be learning principally about Isaac Newton. Now, one of the good things about studying Isaac Newton as opposed to Archimedes or Euclid is that we know a lot about him. We have his correspondence, we have his principal academic works we can look at to know something not only about his achievements, but know something about him as a person. So in our readings regarding his achievements, we're going to be learning about a few things specifically. One of them is the binomial theorem. And you might know the binomial theorem as just a way to take a binomial, a plus b, and raise it to some power and figure out what the result will be. So that idea was not new to Newton, but what was new was the idea of raising that binomial to some power that is not an integer. So that idea that Newton had about extending the binomial theorem actually had important implications for his development of calculus, of which he's famous for. Another thing that he did that is of some importance is he, in his studies, which sort of involved the binomial theorem a little bit, came up with a new way of approximating the number pi. Now, you might remember that Archimedes famously approximated pi by approximating the circumference of a circle using inscribed and circumscribed polygons. And Newton's approximation is entirely different. Rather, it uses infinite series in a clever way that we will see. Now, as a person, Newton was sort of a turbulent personality, and we'll be learning from a current expert on Newton, that is William Dunham, about Newton's life and his interactions with other people. One of those people with whom Newton interacted was Gottfried Leibniz, who is a co-developer of calculus in the 17th century. So he and Newton developed calculus independently, and there was a controversy about who had developed it first. So Newton was someone who was not as interested in publishing things quickly. And so a lot of his development of calculus sort of sat in drawers or maybe in private correspondence when perhaps it should have been published. So Leibniz did not know this. So anyway, they started a correspondence where there was some dispute about the development of calculus and who did what first. Now, one place where Leibniz is definitely the winner in this whole controversy down to the modern day is the notation that we use for calculus. So if you think about the integral sign, this elongated s, and the fractional symbol dy dx for the derivative, both of those notations come to us from Leibniz. And in fact, they can be dated to some of Leibniz's correspondence from October of 1675. So anyway, this is going to be a very interesting week of material, and I hope that you enjoy it.